The James Webb Telescope has given us the best view yet of our nearest planet, Proxima B. The new image shows a place similar to Earth, but full of dangers, including bad radiation and large temperature fluctuations. It's a place where water could exist, so we wonder if life could exist there. The intriguing image raises one big question. Could life survive on Proxima B? Learn about this shocking mystery that could reveal an alien civilization intent on taking over and changing our world forever. Proxima B is a planet similar to us, but full of challenges. Scientists are looking for planets similar to Earth, and one of the most promising ones they have found is Proxima B, the closest exoplanet to us. Thanks to the James Webb Space Telescope, we now have a clearer picture of this planet. It looks a little like Earth, but there are big differences. The planet orbits the star Proxima Centauri, which is more than 4 light-years away. It's a distance that's impossible to overcome with current technology, but there are plans for future missions that could bring us closer. While studying the new data, scientists have discovered a mysterious signal hinting at extraterrestrial life on Proxima B. Learning more about it presents both exciting opportunities and great challenges. It's close enough to consider exploring, but its environment is extreme and difficult to survive. But that's not the worst part. There are several features that raise serious questions about whether life could exist there, and we still have a lot to learn. The planet orbits its star in 11.2 Earth days, which means it is very close to Proxima Centauri. What's even more interesting is that it is in the star's habitable zone, the region around a star where conditions could allow the presence of liquid water, which is essential for life as we know it. This fact has caused quite a stir among scientists and the general public. This delicate balance, where some factors are ideal for life while others make it uninhabitable, is what makes this planet so fascinating. Another big problem is that it is tidally locked, meaning that one side of the planet is always facing the star while the other remains in the dark. As a result, one side can be very hot and the other very cold. However, the debate over whether life could exist there under these extreme conditions continues. It may seem like a harsh place, but this planet is forcing us to rethink what we know about where life could exist. And that's not all. New technologies, such as telescopes and instruments like the espresso spectrograph, have made it easier for us to study distant worlds like these. These tools help us better understand the physical properties of these planets, and may even provide clues as to whether life could exist there. There's also an exciting project called Starshot, which aims to send a small probe to Alpha Centauri, the nearest star system, to learn more about these planets. This project shows just how committed we are to exploring the universe and discovering if life exists beyond Earth. But the journey to this planet is never easy. But human innovation always finds ways to push boundaries and explore the unknown. The scale of the Starshot initiative is enormous. Launching this probe requires as much energy as the entire United States uses, but it only takes 10 minutes. Once in space, the probe will travel for 20 years to reach Alpha Centauri. Once there, it will take about 2 hours to collect all the necessary data and send it back to Earth. It will take another 4 years for that data to reach us, making communication over such great distances extremely difficult. But the potential rewards are equally enormous. A successful exploration of this planet could change the way we see ourselves and our place in the universe. We could learn more about how planets form and evolve beyond our solar system, and whether life exists elsewhere. The knowledge gained from this mission will give us a deeper understanding of planets like our own and help answer one of humanity's most important questions. Are we alone in the universe? Dreaming of new planets pushes the boundaries of possibility. But research comes with responsibility. If we decide to visit or colonize another planet, we must consider important ethical questions. What are our responsibilities as we explore and potentially change the environments of other planets? How can we be sure that even the simplest of things won't harm or disrupt potential life? But this isn't the biggest problem we have to face. The very act of exploring this planet represents the beginning of a new chapter in humanity's quest for understanding. The nature of the land gives us hope, but its harsh conditions remind us that we face serious obstacles. The tools we use, like telescopes and other advanced equipment, help us discover more than we ever thought possible. This initiative helps us understand what makes a planet habitable by demonstrating our willingness to push boundaries and explore distant worlds. Humanity's desire to explore the unknown keeps us moving forward, even when the path ahead seems impossible. We explore the deepest mysteries of the universe, not only by exploring distant planets like these, but also by exploring the massive black holes at the centers of galaxies, including our own Milky Way. It's amazing how something as powerful as a black hole can be hidden in the fabric of space, giving us a glimpse into the deepest secrets of the universe. Superstring theory deals with the smallest parts of the universe, and it can help us understand some of the strange things that mainstream science struggles with. For example, it can explain the strange properties of black holes, which challenge our understanding of gravity and quantum mechanics. By studying black holes using this theory, scientists hope to answer important questions about how the universe works and how everything began. But studying black holes isn't easy. These massive objects don't emit light, so they can't be seen with regular observatories. The research is made more difficult and uncertain because scientists have to rely on indirect methods, such as observing how nearby stars and surrounding gas move. In addition, the theory itself is complicated. She argues that the smallest particles of matter are not tiny dots but vibrating strings. The theory is an attempt to combine quantum mechanics, a difficult problem in physics, with Einstein's general theory of relativity. The theory also suggests that there are 10 dimensions, 6 more than the 3 dimensions of space and 1 dimension of time that we experience every day. These extra dimensions are thought to be too densely packed for us to see or measure directly, making their existence difficult to prove. Furthermore, theoretical ideas such as wormholes, space-time tunnels that could connect different parts of the universe, add even more challenges. Wormholes are unstable and nearly impossible to study, making their existence even more difficult to confirm. This means that most of what we know about black holes and related topics is still theoretical. We rely on advances in theoretical physics and observational technology to better understand them. The theory even proposes a new version of the Big Bang, suggesting that our universe may have been created by the collision of other universes or some kind of cosmic birth. She suggests that wormholes could be tunnels between different regions of space and time. If wormholes are real and stable, they could change our ideas about the universe, and even reveal that black holes are gateways to other dimensions. But here's a surprising idea. Could our entire universe be inside a black hole, part of a much larger universe? This would turn our basic ideas about beginnings and existence on their head. As we delve deeper into these cosmic mysteries, our curiosity grows and we learn more about the universe. One star that scientists are keeping an eye on is Betelgeuse, which has recently shown a dramatic change in brightness. This has caught the attention of astronomers and led to speculation that it could soon explode as a supernova. This change in brightness challenges what we know about stars and brings us closer to seeing a rare and spectacular event that could light up the sky for weeks. The recent increase in brightness recorded by telescopes highlights the dynamic changes that occur in the life cycle. This star in Orion used to shine constantly, but now it is much brighter, making it a prominent feature in the night sky. This change is not trivial. It represents a major change in the star's temperature, size, or energy output, showing how unpredictable the star can be. The brighter it shines, the more attention it attracts from both astronomers and scientists alike. Carefully monitoring every little change in its behavior helps us learn more about the star's life cycle. Using instruments like telescopes, we gain valuable information about how the star evolves, giving us a clearer picture of the universe and giving stargazers a dazzling view of the night sky. When we study stars and other celestial bodies in the vast universe, we realize that what we know is only a small part of a much bigger picture. Often, what we expect to see in the universe does not always match the reality of what is actually happening there. Consider, for example, neutrinos, tiny particles that weigh almost nothing and are often overlooked. But these particles play a big role in the lifespan of stars. When a star like Betelgeuse is nearing the end of its life and is preparing to explode as a supernova, it is not just light that tells us that something big is about to happen. Neutrinos, which interact very little with other matter, could be the first sign that Betelgeuse is about to go supernova, providing an early warning before we can see anything with our eyes. When a supernova occurs and the star's core collapses under its own gravity, neutrinos are released in huge quantities. These particles can leave the star's core almost immediately and travel through space at nearly the speed of light. This means that neutrinos could reach Earth hours or even days before the light from the supernova arrives. This gives scientists a chance to prepare telescopes and other instruments to capture the moment the explosion happens. Detecting these particles is not an easy task because they interact very little with matter. Special underground detectors, equipped with large reservoirs of water or huge blocks of ice, are used to detect the faint signs of neutrino transit. Buried deep to block out other signals, these detectors help scientists detect even the smallest signs of neutrinos. The early warning system they provide is one of the most fascinating and mysterious tools in modern astronomy. Betelgeuse, a massive red supergiant in the constellation Orion, is currently showing significant changes in brightness, causing great excitement among astronomers. These changes could indicate that Betelgeuse is nearing the end of its life and could soon explode as a supernova. If this happens, the explosion will be one of the most spectacular sights in the night sky in recorded history. It will shine so brightly that it can be seen during the day, giving astronomers a unique opportunity to learn more about the life cycle of a giant star. As we continue to explore